Matthews Gatos here. In this video, we're going to look at the derivative of cosine x proved using limits. So let's get started. I know if I want to do the derivative of any function, f of x, I can use tangent definition number 2, which states the limit as h approaches 0, f of x plus h minus f of x all over h. So if I want to use this tangent definition number 2 to prove the derivative of cos x, that means that my function is cos x. It'll look like this. The derivative of cos x is the limit as h approaches 0, cos of x plus h minus cos x all over h. So let's break this down a little bit. So if I want to do the derivative of cosine, I'm going to use this definition here. Now I have cos of x plus h. So that's an angle sum. So on my formula sheet, I'm going to use this angle sum for cosine. So that will mean the derivative of cos x is equal to the limit as h approaches 0. Now let's apply our formula. This is going to be cos of x, cos of h, minus sine of x, sine of h, minus cos of x all over h. Now what I notice is I have a cos x and a cos x. So I'm going to separate this fraction and use properties of limits to rewrite this as the limit as h approaches 0, cos x cos h minus cos x over h minus the limit as h approaches 0 of sine x sine h all over h. So I just separated that into two separate pieces. Now I notice this is the limit as h approaches 0, and I have a cos x. X is not tied to h, so it's considered a constant value. So I'm going to factor that out, cos of x, and that'll be times by the limit as h approaches 0 of cos h minus 1 all over h. Minus. Now over here, again, same kind of line of reasoning. Sine x not tied to h as h approaches 0, so it is a constant value. We'll take that out. Limit as h approaches 0 of sine h over h. So if you didn't watch my last video, I'll go over this again. I want to look at each one of these limits. So in the first one, limit as h approaches 0. I can't sub in because I'd be dividing by 0. There's nothing to factor. There's no obvious conjugate here. So I'm going to look at a graphical or numerical perspective. So here is the limit as x. I'm going to look at cos x minus 1 all over x. This is my graph here. I want to look at the limit as x approaches 0. So I'm going to look at my left-hand side. I can see as it goes to 0, it looks like my function's going to 0. On the right-hand side, also going to a y value of 0. So since left-hand and right-hand limit equal the same, I can safely say that that limit is 0. So back over here, I know that that limit is equal to 0. So I have cos x multiplied by that limit, which is 0. Now let's do the same thing here. Limit as h approaches 0 sine h over h. I can't sub in 0. I'd be dividing by 0. There's nothing to factor. There's no conjugate. So again, I'm going to look at a graphical perspective. So here's the graph of sine x over x. So if I want to know the limit as x approaches 0, again, I start with my left-hand side, and I can see as I get closer to 0 on the left side, it looks like I'm going to 1. On the right-hand side, as I get closer to 0, also going to a y value of 1. So I can say the limit as x approaches 0, sine x over x is equal to 1. So now that I know that limit there is equal to 1, I can replace this here with 1. So what I really have is cos x times 0, which is 0. Take away sine x times 1, which is sine x. 0 take away sine x is negative sine x. So what I did is I proved that the derivative of cos x is equal to negative sine x. Now that we've proved it true for all values of x, we can use that moving forward for all other proofs. So I hope this video helped. If it did, give it a thumbs up so I can help more mathies just like you. Thanks for watching, and I look forward to seeing you for the next one.